When we think of the Australian outback today, we picture sun-baked scrubland and a quiet landscape filled with mostly harmless, familiar wildlife. But travel back 50,000 years, and this arid environment disappears. In its place is a dense, thriving ecosystem, ruled by massive, truck-sized marsupials and towering flightless birds. And stalking those giants was Megalania. This was a colossal relative of the modern monitor lizard, stretching an incredible 7 meters from snout to tail. This was an apex predator with zero natural enemies. Yet somehow, an animal perfectly adapted to dominate this entire continent completely vanished. To figure out how something this powerful could just disappear, we first have to look at exactly how it operated at the top of the food chain. Prehistoric Australia offered a complicated terrain. A hunter weighing hundreds of pounds had to navigate thick forests and heavy undergrowth to locate a meal. It solved this visibility problem with a biological scanner, its long, forked tongue constantly flicked, gathering invisible chemical traces. Because each side picked up scents independently, it determined exactly which direction a smell came from, locking onto targets miles away. The physical bulk of the animal was intimidating, but its true advantage was a sensory network that made hiding practically impossible for anything else in the ecosystem. This is the skeleton of a diprotodon. It was a herbivore roughly the size of a modern rhinoceros and a primary target for Megalania. Taking down a massive animal like that requires extreme patience. The giant lizard would shadow a herd for hours, watching for a single vulnerable straggler to step slightly out of formation. When the moment came, a predator of tremendous mass would suddenly accelerate out of the brush with terrifying explosive speed. It clamped down using heavily muscled jaws lined with thick, serrated teeth, built strictly to tear deeply into hide and muscle instantly. And scientists now suspect the mechanical damage was only the first phase of the attack. Similar to modern monitor lizards, Megalania likely pushed a complex, highly toxic venom directly into the wound. That venom induced massive blood loss and shock. The lizard didn't need to physically rustle a struggling giant to the ground. It just had to deliver one glancing bite, retreat, and wait for the toxins to do the work. It stalked, ambushed, and poisoned. It was an evolutionary marvel, perfectly calibrated to systematically dismantle the largest land mammals of Pleistocene Australia. About 40,000 years ago, the global climate cooled. Rainfall plummeted across the continent, ancient water sources dried out, and the thick vegetation disappeared. This flowchart shows the cascading ecological reaction. As plants died off, massive herds of giant herbivores dwindled. A 1,000-pound predator requires tremendous daily calories to survive. When these giant mammals collapsed, Megalania's massive energy supply was cut off entirely. The extreme size and heavily specialized diet that allowed this lizard to rule for millennia ended up being the exact traits that starved it out. Around this exact period, human beings arrived on the continent. For a brief span of thousands of years, people shared the landscape with an active, venomous predator the size of a truck. The creature faced a fatal intersection of pressures all at once: a drying climate, collapsing food sources, and the sudden introduction of new, highly intelligent human hunters. Unable to adapt fast enough, the apex predator was eventually wiped out. Today, we only know it ruled because of the scattered fragments of bone it left hidden in the dirt. It proves that no matter how large, strong, or perfectly adapted a creature is, it is ultimately at the mercy of its environment. Megalania may have faded into extinction, but its massive frame, its deadly bite, and its extraordinary story make it the closest thing our world has ever known to a true living dragon.